This puzzle's called Scattered Sums Sudoku by Bill Murphy. I got it from the Sudoku testing submissions channel of the CTC community Discord. Let's take a look at the rules. So clues outside the grid give the sum of the shaded cells in that row or column. So these three digits are gonna, those three digits are gonna add up to 12. These four digits are gonna add up to 13. These two are 7, and so on. I think that's a pretty simple rule set. Uh, yeah. I don't know how hard this is. It was like literally just posted like less than 5 minutes ago. I saw it was posted or saw that there was a new message and was like, hey, that looks pretty cool. So I thought I would give it a try. I'll put a link to the puzzle down in the description if you want to give it a try yourself. Let's get started. So the first thing I see is this 6 clue. 6 in 3 cells can only be made one way, 1, 2, 3. That's just a, if you're wondering how I know that so quickly, it's just like a very common thing that you need in variant Sudoku is just what sums can you make in 3 digits, and so you just kind of learn some of the things like 6 is 1, 2, 3, 7 is 1, 2, 4, 24 is 7, 8, 9. It's not any fancy thing I'm doing. So 20, when you have to use a 1, 2, or 3, can actually only be made in one way. The most we could make these two digits add up to is with an 8 and a 9. We could make this 17, so we need a 3, which will make that a 3, and then 1, 2. Okay, so now, could we make this a 9? If we made this a 9, we would need these two to add up to 3, which would have to be a 1, 2. But now we have 3 1, 2s in box 2. Of course, there can only be 2 digits from 1 and 2 in a single box or a row or column. So that's not going to work. So this must be an 8, this must be a 9. We need this to add up to 4 now instead of 3. So to get to 4, you have to do 1 and 3. So that's a pair, so this can't be a 1. So this must be the 2, this must be a 1. Okay, so these two must add up to 14. 15 in total minus 1. 14, and we can't use a 9. Must be 6, 8. And, okay, we can just go right down this line. So if we made this an 8, that would be 17. We need 19 total, so these two would have to add up to 2. And you can't make 2 in just 2 digits. You could do a 1 and a 1, but obviously that doesn't work. 2 and 0 doesn't work either, of course. So this can't be an 8, so this is a 6. Okay. Can we keep just going down the line? Oh yeah, we can. So this is 15. We need 4 again to make 19. Has to be 1 and 3. Oh, and then, okay, I didn't see this earlier. 10 in 4 digits is 1 plus 2 plus 3 plus 4. It's just all the minimum digits added up. The first 4 minimum digits make 10. So we figured that one out. So I don't know exactly how this is going to go, but both of these digits must be fairly small. Obviously, this is already a 2 or a 4. This is at most a 6, because we could, yeah, at most a 6 for a 12. So this is at most 10, which means this is at least 14, which means these are fairly big numbers then. Oh, wait, here's 24 and 3 digits. This must be 7, 8, 9. I even said that at the beginning. I didn't even notice it. Okay, so we can kind of do the opposite. This was minimums and then we had to maximize. Well, this is maximums and now we have to minimize for this for this row. If we tried to put an 8 or a 9 in here, we just couldn't fill this sum. It would be too big. So if we make it a 7, we can do 1 and 2 to make it add up to exactly 10. Let's see. 13. No, that we could just barely do it. I was thinking, could we make this a 4? If we make this a 4, we could do 1 and 8, and that would be exactly 13. And I think that would work. 4, 1, 2. Yeah, I think that would work. At least at a glance, it seems like it works. Okay, what about these on the outside? Needs to add to 15. There's only 2 ways of making 15 in 2 digits, 6 plus 9 or 7 plus 8. This can't be an 8, so then this can't be a 7. Oh, well now we need to make this add up to 9. Well, we can't use 9 in a 2 digits added together to make 9. So this can't be 9, so this can't be 6. So now these two add to 9, so this has to be 1 or a 3. which makes this a 6 or a 4 to go with the 1 or the 3. And then do these match up? 9 and 4, 6 and 7. Yep. Okay. So we have a little ring going on here. Yeah, I don't... I think if we got any one digit there, we would know all of the digits, but... Yeah, well, I mean, that would definitely be the case. If we knew any one digit, we would know all of the digits, but... Unfortunately, we don't know any of the digits. Maybe there's an option here that... Or this is more constricted than I'm realizing. Let's see. Let me look up the options for 12 and 4 digits. And let me put this on the screen so you guys can see that too. So these are the two options for 14 in... what did I say? 14 in 4 digits. Sorry, I don't know, my mind just like totally went blank there. And I was thinking we couldn't have a 3 in this sum, but we can have a 3. If this is the 3, well, but then we can't have a 1. Yeah, this can... Yeah, I was right. We can only use one of 1 or 3. Because these two cells can't be a 1 or 3 because we already have a pair. So we can have one of 1 or 3 in the sum, and we're always going to need a 1. Both options have a 1 in there, so this must be a 1. And then we need 1, 2, but not 3, so we need 4 and 5. There we go, that's going to resolve that. Could have done that a little bit earlier, but didn't realize just quite how constricted that was. Okay. So actually, now we can do this row. So if we basically maximize the cells and just make everything as big as possible, this would be a 5 plus a 2. Then we would have another 8 and 9, so this would be 7 plus 17, which would be 24. If we make anything not maximum, then of course we wouldn't add up to 24 anymore, so we have to do everything maximum. And then, yeah, that'll be 24. 13, so this does end up being the 4, so we can do the one case that I said worked, was 4, 1, and 8. This 1 is going to make this a 2, 1. Let's do this math. That's 6, we need 13, so we need a 7. We have 9, we need 11, we need a 2. Oh, this 1 is figuring out the outside now. So this is a 3, this is a 6, this is a 9, and this is a 4. Okay, so we finished all the sums, now it's just basic Sudoku. We have 2 6s looking up, so that's a 6 there. 1, 1, 1 looking into box 3. We need a 1 there. 1, 1, and a 1 looking into box 7 puts a 1 there. 8s looking into box 7 puts an 8 there. 3 in one of these two spots, 4 in one of these two spots. Oh, 3 looking into box 3. We need a 3 in row 1, needs to be right there. That's a 3. I have the feeling I'm about to sneeze, so I apologize if I randomly just stop what I'm doing and mute, but that's the explanation. Okay, so this is... what do we need in here? We need a 6, 8, and a 9. This can't be 8 or 9, so this is the 6. This can't be 6 or 9, so this is the 8. And there we go, finish that off. Nope, not quite sneezed yet. One sec, I'm gonna go blow my nose. Sorry about that. It felt like every time I was talking, I was about to sniffle, and I didn't want to sniffle on camera, of course. Yeah, just figured I might as well get it out of the way intentionally rather than being uncomfortable while recording. So what's left in this row? We need a 1, we need a 5 and a 6. Oh, I could have just seen 6 and 6 are looking over to put the 6 there. So we have a 1, 5, we have a 1 looking up. So that's resolved. 4 is looking down into this box, so we have a 4 in one of those two spots. And also a 4 in one of those two spots. And a 4 in one of those two spots. Okay. What's left in this column? We need a 4, we need a 7, and a 2? Is that right? Yeah, so this is just a 4 because we have a 2, 7 in the row. We have a 2 right here to figure that out. And that can't be a 4 anymore. What's left in this? We have a 3. Oh, 2 just goes right up here. We have a 2 looking in. So this is just a 2. Then we can do a 3 and a 4. Whoops, that's supposed to be a little 4. They're definitely not both 4, I can tell you that. Okay. We have a 2. So 2 is in one of these two. I guess that's not super helpful. 4. No, we already did 4. 7 or 8. 8 is down here somewhere. 8 can really be anywhere there. 1. 2 is, 2 is down here with the 4s. We have these 2s looking. Actually, we have this 2 as well. So this is a 2, which makes this a 4, and I think finishes. No, not quite. There are a couple more 4s left. I was going to say finishes off the 4s, but actually there's 3 4s left, so not even that close. We have a 6 here, which places a 6 in box 9. This is 5 9. This is 5. What is that? 5 6. No 5 6s. I swear I was perfectly fine before I started recording, and now I'm coughing. My nose is running. This is a 5 or 7. This 5 9 pair is looking up, so this is a 7. This is a 5. What's left is a 2 8. Oh, and we have a 2 and an 8 looking over, so we can figure that out pretty easily. This 2 rules out this 2, so that's a 2. And that's all the 2s. I think I'm actually right about that this time. So this is 7 and 9 remaining. Let's look across the top. We need a 5 7 8. This can't be 5 or 8, so this is a 7. I don't think we have anything else to help there, unfortunately. What about these? We have a 4, we need a 9, and we need a 6. This 6 is looking up. These two can't be 6, so that's a 6. Okay, what? No, I don't. Oh, no, that 6 is resolved. I was like, whoops, that's supposed to be a 5. I was confused because there were so many different digits, and so I knew something had to resolve, but I couldn't I couldn't see what was supposed to resolve. For this row, we need a 4, 7, and a 9. Can't be a 9, so this is just a 4 or 7. For this box, we need a 4, 5, and 7. One of them must be a 5 down here. Okay. I keep looking at the clues like they're going to suddenly give me a hint about what to do next. But we've literally done everything with the clues, so we don't need to worry about that. My mind just needs to accept that. We need a 7 as well, and there's a 7 right here. So this is the 7. This is a 5. This is an 8. This is a 5. Yeah. Is that all the 8s now? That's good. I like, is it the New York Times Sudoku where it grays out the digits when you've done all of one digit? And I think the CTC app does that as well, actually, now that I think about it. I really like that. It really helps making you feel like you're making progress. This can't be a 6 or a 3, so this is just a 9. Whoops, wrong button. That has to be a 9. This 5 makes that like that. Oh, I guess this is a freebie. I don't even need to think about this. This is 5. This is 3. What is this? 9 and 7. There's a 9 up here, so this is a 9. 7. Now this 3 makes this a 4. So this can't be 4, can't be 5 either. Just makes it a 7. Whoops, though. I can't type sometimes either. There we go. That was not tricky at all. Probably like a 1.5 out of 5 for difficulty. But I guess, yeah, you really need to know your sums. Like your triplet sums and even some quadruple sums. Was it the 12 that I had to look up to make sure? I knew it was constricted, but it's easier to look up. Just look up all the combinations rather than trying to figure them out on the top of your head. Yeah, but that was a fun quick solve for just after midnight. So thank you, Bill Murphy, for that puzzle, and thank you all for watching.